Jai Hind, myself Dr. Alok Vardhan. Currently, I am working as an assistant professor in the Department of Mechanical Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. Today, I will discuss one of the complex topic of the subject renewable energy resources. Today I will discuss about solar collectors. So these are the content of my today presentation. In this lecture, I will discuss solar collectors, then classification of solar collectors, then what is concentrating and non-concentrating type collectors, its types and its relative merits and demerits. So what is solar collector? So basically solar collectors are used to collect the solar energy, and these energy convert the incident radiation in thermal energy by absorbing them. So this heat is absorbed by following fluid in the tube of collectors, and these are of two types. Number one is non-concentrating type collectors and number two is concentrating type collectors. In subsequent slide, I will discuss in detail what is non-concentrating type, what is concentrating type collectors. Then what is non-concentrating type collectors? So in this collectors, the area of the collector to intercept the solar radiation is equal to the absorber plate and has concentration ratio of 1. So non-concentrating type collectors has the concentration ratio of 1, and further this can be categorized as flat plate collectors, vacuum tube collectors and unglazed flat collectors. So these are the classifications of non-concentrating types collectors. Then what is flat plate collectors? So basically it is the most important part of any solar thermal energy system. Direct as well as diffuse radiation both, and converts these radiation into useful heat. Okay, and it is suitable for heating temperature below 100 degrees Celsius. So this type of collector are best suitable where temperature is below than 100 degrees Celsius. This is the pictorial representation of liquid flat plate collector. This is the casing. This is the transparent cover, this one. This is the thermal insulator body. This is tubes. This is tubes where liquid is flowing, and this is diffuse radiation which is coming from the sun. So this is the pictorial representation of this liquid flat plate collectors. Then what is the advantages and disadvantages of this flat plate collectors? So the first advantages is it utilizes the both beam means direct as well as diffuse radiation for heating, and it requires less maintenance. Okay, so these are the disadvantages. These are the advantages. Then what is the disadvantages? So it requires in flat plate collectors large heat losses by conduction and radiation process and no tracking of sun. Okay, and the other disadvantage is low water temperature is achieved. So by the help of this flat plate collectors, low water temperature is achieved. Then second non-concentrating type collector is vacuum tube collectors. Basically, it looks like fluorescent lamps, contains several individual parallel glass tubes, and each tube contains an absorber tube bounded to a heat pipe covered with selective coating and suspended in vacuum. These two collectors are more efficient compared to flat plate collectors, and they perform well in both direct and diffuse type of solar radiation. These collectors are best suited for moderate temperature application, where so these are the some features regarding vacuum tube non-concentrating type collectors. So this is the pictorial representation of vacuum tube collector. Okay, here this is glass metal seal, and this is tubes where fluid in and out. Okay. Then third types of non-concentrating type solar collector is unglazed flat plate collectors. So it's basically this is designed for low temperature applications such as heating of swimming pools, etc., where demand of temperature is at below 300 degrees Celsius. So for this temperature range, we can select unglazed flat plate collectors. Then it is made of either rubber or UV stabilized back polymer plastic, and a large portion of sun's energy is absorbed and lost both due to the absence of glazing, and having life span of 15 to 20 years for this type of collectors. Okay, so this is the pictorial representation of this unglazed flat plate collectors. Okay. Now, what is the material for flat plate collectors? So basically, material needed for flat plate collectors can be classified into these following groups. Number one is physical properties. So the material for flat collectors should have tensile strength, density as well. And if you are talking about its thermal property, so it should have thermal conductivity and heat capacity. Regarding environmental property, it should have corrosion resistant, degradation of material due to UV radiation and moisture, and penetration, etc. So the material generally used for various components of a flat plate collector are given below. So for absorber plate and tubes, the material should have high tensile strength, high thermal conductivity, and it should also have corrosion resistant. So generally for absorber plate and tubes, it is made of copper, aluminum, steel, and black chrome, black copper oxide, and black nickel are used for its coating to having high absorptivity. Okay. Then if thermal insulation, for thermal insulation, the material used for insulation should have low thermal conductivity, stability at high temperature up to 2000 degrees Celsius, and non-corrosive. So in this regard, the material are mineral wool, rock wool, glass, thermal cold foam, etc. Then transparent cover plate. For transparent cover plates, the material should have high strength, high solar energy transmittance, and high durability. So the material should have the materials for this is toughened glass. Okay, toughened glass with thickness 4 to 5 mm. Okay. Then for casing, it should have the above component which is placed at an angle facing south at an inclination to the horizontal equal to the latitude of the place plus 150 degree. Okay, so for this the material is aluminum, steel, fiberglass, and rectangular shape. Then what is the material for selective coating? So for selective coating, the material should have high absorptivity and low emissivity. Okay, so for selective surface, the material should have nickel, aluminum, nitride. Okay. So these are the materials for flat plate collectors. Then what are the factors which affect the performance of flat plate collector? So these are some parameter. The performance of the flat plate collectors depends upon these parameters. So the first parameter is incident solar radiation. So as the solar flux increases, the heat absorbed by the collector increases. So the performance of the collector improves. Okay. Then second parameter is selective surface. So by using materials for surfaces which are highly sensitive to the radiation and that absorbs maximum energy. So and the temperature should also vary between 3000 to 4000 degrees Celsius and should not oxidize and not be corrosive. Okay. Then third parameter is number of cover plates. the increase in number of cover plate reduces the internal convective heat transfer, heat losses, but also prevents the transmission of radiation inside the collector. So more than 2 cover should not be used to optimize the system. So, okay. And then last, the other parameter is spacing between absorber plates and glass cover. So the more space between the absorber and the cover plate, the less internal heat losses. So the collector efficiency will be increased. So however, on the other hand, increase in space between them provides the shading by sidewall in the morning and evening and reduces the absorber's roller flux. Then other parameter is collector tilt. So the flat plate collector do not track sun and should be tilted at angled attitude of the location for an average better performance. So the collector is placed with south facing at northern hemisphere and to receive maximum radiation throughout a day. Then other parameter is fluid inlet temperature. So as the inlet temperature of the fluid increases, the operating temperature of the collector increases. So this leads to increased losses and decrease in efficiency. Then the other parameter is dust on cover plate. So the efficiency of the collector decreases with dust particles on the cover plate because the transmission radiation decreases by 1% and frequent cleaning is required to get the maximum efficiency of collector. So these are some parameters on which the efficiency of the flat plate collector depends. So the next type is concentrating type collectors. So what is concentrating type collectors? So these type of collectors are also known as focusing type collectors. These are used for medium and high temperature range. For medium temperature range, the temperature should be 100 to 3000 degrees Celsius, and for high temperature range, the temperature should be above 3000 degrees Celsius. So these are used for medium to high temperature application. The collectors in this type of collector system comprises of a concentrator and absorber. Absorber means receiver, and the concentrator is an optical system in the form of reflecting mirrors or reflecting lenses. The collector is, this type of collector is installed with a tracking device for continuously following the sun. The receiver includes an energy absorbing surface, transparent cover and other accessories. Okay. And this type of system receives the solar radiation on the large concentration area and focus it onto an absorber having relatively much lesser area. And these systems have high collector efficiency, which is lies between 50 to 70%. So we can say that concentrating type collectors have higher efficiency compared to non-concentrating type collectors. Then what are the types of concentrating type collectors? So these are further divided into two categories: focusing type, also known as concentrating type collectors, and non-focusing type collectors. So focusing type collectors are further classified into parabolic through reflector, mirror strip reflector, Fresnel lens reflector, parabolic disc collector. And non-focusing type collectors are further classified into flat plate collector with plane reflector and compound parabolic concentrator. So these are the classifications of concentrating type collectors. Then what is focusing type collectors? So we know that there are many types of focusing type collectors. So in subsequent slides, I will discuss one by one what is parabolic through reflector, what is mirror strip reflector, what is Fresnel lens reflector, and what is parabolic disc collector. So if we are talking about parabolic through reflector, so this is the pictorial representation of this parabolic reflector. So basically in this type of reflector, the solar radiation falling on the area of the parabolic reflector are concentrated at the focus of this parabola. So all the rays are finally focused on this parabola. Okay. And these are usually made up of highly polished glass-like shine surfaces, and the temperature at the absorber tube is obtained at nearly 4000 degrees Celsius in the case of this parabolic through reflector. And because of its parabolic shape, it can focus the sun at 30 to 100 times its normal intensity and intensity on a receiver. Then second is a mirror strip reflector type concentrating collector. So basically it has plane or slightly curved mirror, plane or slightly curved mirror. These are the mirror strips, and mounted on a flat base. This is base and this is mirror strip. The individual mirrors are placed at such an angle that reflected solar radiation falls on the same focal line where the absorber pipe is placed. Then the collector pipe is rotated so that the reflected rays on the absorber remain focused with respect to changes in sun's elevation. Then the third type is Fresnel lens concentrating type collector. So basically in this collector, a Fresnel lens, this is Fresnel lens, which consists of fine linear grooves on the surface of refracting material of optical quality on one side and flat on the other side is used. This type of solar radiation which falls normally to the lens are refracted by the lens and are focused on a line. Focus on a line where the absorber tube is placed. So this is the absorber tube. A Fresnel lens collector is generally made up of acrylic plastic sheets having overall dimension of 4.7 meter into 0.05 meter. Then the last type is parabolic disc collector. So basically it is a point focusing type collector which has mirror-like reflector and an absorber at the focal point, and the concentrating ratio of these collectors is 100, and the temperature of the receiver can reach up to 2000 degrees Celsius. These collectors have higher efficiency for converting solar energy to electricity in small power plant. So this is the pictorial representation of this parabolic disc collector. Then if we are talking about non-focusing type collectors, so the first classification is flat plate collectors with plane refractor. So basically it uses a flat plate. This is flat plate with a plane mirror, and this is flat plate with a plane mirror attached to its edge to reflect the additional solar radiation into the receiver, and thus the total solar radiation received by the receiver is increased here, and the mirror used are called booster mirrors. Okay, and these collector utilize direct and diffuse both type of radiation and achieved fluid temperature higher by 300 degrees Celsius than in flat plate collectors. Okay. Then second type is compound parabolic concentrator, also known as CPC. So this is the pictorial representation of compound parabolic concentrator as CPC. So basically it is also called Whiston collectors, and it consists of two facing parabolic mirror segment to a flat plate receiver, which is also known as the absorber, and it collects both direct as well as diffuse type of solar radiation with a high acceptance angle and requires occasional sun tracking. And in this type of collector, the temperature can be achieved by 1500 degree Celsius to 2000 degree Celsius. Okay. So what are the advantages and disadvantages of concentrating collectors over flat plate collectors? So the first advantage is the cost of the concentrator system या unit area is less. So these are the first advantages of concentrating collectors over flat plate collector. Then it requires less observer area, and then it has high collection efficiency because here losses are less. And then last advantage is it's suitable for large power generation since it can achieve high temperature of the fluid So the efficiency is high in the case of concentrating collectors over flat plate collectors. Then what are the disadvantages of concentrating collector? So the first disadvantage is it's need tracking. Okay, it's need tracking of the sun, which increases the capital cost. Second one is diffuse solar radiation cannot be collected on the receiver, and it requires higher maintenance to retain the quality of reflecting surfaces. And the last disadvantage is it has high initial cost and maintenance cost. So these are the advantages and disadvantages of concentrating collector over flat plate collector. So this is all about regarding solar collectors. Thank you.